and welcome to today's webinar, NGINX Kubernetes Ingress Controller Getting Started. I would like to introduce today's presenter, Michael Pleshakov, Platform Integration Engineer at NGINX, and he will take you through today's webinar. To ask any questions, please submit them via the question box, and Michael will answer them. As a bonus, there will be a prize for the best question. Please note, a recorded version of this webinar will be available after the event. I would now like to hand you over to our host, Michael.
Hi, everybody. Thanks, Stephen. Thanks so much for introducing me. Before we proceed, we'll do a quick poll. I would like to ask you a question. Are you familiar with Kubernetes or completely new to it? And you should see the questions appear on your screen. And while you're answering this question, this is our agenda for today's webinar. We will start with a brief discussion of Kubernetes key features. Then we'll talk about application delivery and see how the Ingress resource and Ingress controllers help to deliver web applications on Kubernetes. We will introduce our own NGINX and NGINX Plus Ingress controllers and show a live demo. In the demo, we will deliver a simple web application. At the end, we'll talk about advanced configuration methods. Those methods will help you support a wide range of advanced application delivery use cases. And finally, we will answer your questions that you can ask during the webinar. This webinar assumes that you have some basic knowledge of Kubernetes. And looking at your answers, it looks like some people are not familiar with Kubernetes. And for those people, I'd recommend to go through any introductional Kubernetes tutorial first. And you can always go back and watch this webinar later on demand. So let's start. Last year, we saw how Kubernetes became the leader in container orchestration. Every year, we survey our users, and last year we saw that Kubernetes was part of planned technology stack for 29% of them. Kubernetes has one of the largest open source communities, and it also has a vibrant ecosystem of service providers and vendors who provide a solution and services for Kubernetes users. And it's worth mentioning that all major cloud providers now offer Kubernetes as a service. One of the reasons of Kubernetes success is the set of features it provides. With Kubernetes, running and managing applications across a cluster of machines is easy. Kubernetes adds resilience to your applications by monitoring the health and restarting any failed workloads. If you're developing microservices, Kubernetes internal load balancing and service discovery help you stitch your microservices together. Kubernetes also supports running stateful applications such as databases or key value stores. And of course, many other useful features are available as well. So once you have a web application up and running in a Kubernetes cluster, how do you deliver that application to your users? Many of you know NGINX. NGINX is an open source solution for load balancing, reverse proxying, content caching, and web serving. According to the recent web serving ranking from W3Techs, NGINX was used to deliver 63% of top 10,000 busiest websites. Also, NGINX is currently #1 downloaded application container image on Docker Hub. The fact that NGINX is lightweight and it has a low memory footprint made it popular in the container world. In addition to the open source NGINX, there is a closed source commercial version called NGINX Plus. This version brings additional features for application delivery. Features such as active health checks, advanced load balancing algorithms, dynamic reconfiguration, and monitoring. In this webinar, we'll see how to use NGINX and NGINX Plus for application delivery on Kubernetes. This is our application delivery example. On the right, you can see a Kubernetes cluster. While such a cluster can have multiple nodes, for simplicity, we depict it only by one rectangle. And in this cluster, we deployed 3 replicas of a simple web application called app. On the left, you can see some users who want to access our application through the internet. So how do we deliver the application to our users? So what does it mean to successfully deliver application? Here you can see the requirements for successful application delivery. First, we should provide a stable public endpoint for our users. That endpoint can be a DNS name or a static IP address and port. Second, performance. Our users should not experience any delays while accessing the application. Third, scalability. We should be able to increase or decrease the number of the application replicas according to the demand. Fourth, reliability. In case of a failure of an application component, our users should not notice that. The failed component itself should be brought back to a healthy state. Fifth, ease of configuration. Creating, deploying, and maintaining the configuration for application delivery should be an easy task. Sixth, visibility. We should be able to understand how the application is being delivered, both in real time and over a period of time. To do that, we need to have access to the application delivery metrics, such as the number of handled requests per second or the average response time. Seventh, security. We must secure the client connections to the application with TLS. And finally, eighth, routing. We should be able to route client requests to an appropriate application component based on the request host header, URI, or cookie. As you will see in this webinar, Kubernetes with its Ingress resource and NGINX Ingress controller can successfully address all of these requirements. What is an Ingress resource? Since version 1.2, Kubernetes includes the Ingress resource. This resource allows us to define rules for an edge load balancer. These rules route client requests to the appropriate application components. You can route a request based on its host header or its URI. Additionally, you can secure connections between the clients and the edge load balancer using TLS. On the left, you can see an example of an Ingress resource. Here we deliver an application through the hello.example.com DNS name and a /path. We will get back to this Ingress resource in our first demo and discuss it in more details. Although Kubernetes includes the Ingress resource, it does not include an edge load balancer to apply those routing rules to. It is up to the user to choose a load balancer. Load balancers by themselves do not understand Ingress rules. In order to make the load balancer understand those rules, the user must deploy special software that first converts Ingress rules into the load balancer native configuration, and second, applies that configuration. That special software is called the Ingress controller. There are Ingress controller implementations for many load balancers, software, hardware, and cloud load balancers. Be aware that it is common to refer to both the edge load balancer and the Ingress controller software as the Ingress controller. And we will follow this convention through our webinar. And at NGINX, we have developed an Ingress controller for both NGINX open source and NGINX Plus. One of the great advantages of NGINX is the ability to run it inside a Kubernetes cluster as a regular Kubernetes application. And this is true for our Ingress controller as well. We deploy the Ingress controller as a Kubernetes application along with along with NGINX in the same container, in the same pod. How does the Ingress controller work? Well, first, it fetches the created Ingress resources, as well the application backend endpoints through the Kubernetes API. Then, based on those resources and the endpoints, the Ingress controller generates NGINX configuration files, and then finally it reloads NGINX to apply that configuration. And all this happens in a loop, so that if you create any additional Ingress resources or change an existing one, the Ingress controller will generate and apply the updated configuration. In case of NGINX Plus, the Ingress controller also takes advantage of the NGINX Plus API, so that it adds or removes backend endpoints through the API, avoiding configuration reloads whenever possible. So how do we successfully deliver a web application on Kubernetes? Well, we use the NGINX Ingress controller. However, our Ingress controller is running inside the cluster, and this means we need to expose it to the internet. Otherwise our users won't be able to connect to it. There are several options how you can expose the Ingress controller. And those options depend on where you're running your Kubernetes cluster, on premises or in the cloud. The first option for on-premises Kubernetes clusters is to expose the Ingress controller pods on some nodes of the cluster. In this case, you would use a daemon set resource to deploy the Ingress controller on a subset of nodes with exactly one Ingress controller pod per node. You would also use Docker port mapping to expose ports 80 and 443 of NGINX on ports 80 and 443 of those nodes. And assuming that all those nodes have public IPs, our users would use those IPs to access the Ingress controller pods. For this option, it is very important to configure high availability among the Ingress controller nodes. And we need high availability here so that in case of a node failure, its IP address is reassigned to a healthy node. Another option for on-premises clusters is to expose the Ingress controller through a basic TCP load balancer. In this case, you would use a deployment resource to deploy the Ingress controller pods. And for simplicity, on this diagram, we have only one Ingress controller pod. However, we can have as many pods as we need. You would create a service with the type node port to expose the Ingress controller pods. The service will expose ports 80 and 443 of the Ingress controller through randomly allocated node ports on every node of the cluster. Between the nodes and the clients, you would place a basic TCP load balancer, which will distribute client connections among the nodes of the cluster. The load balancer will have a public IP address through which the clients will access the Ingress controller. Once a client connection hits a node at the node port, the connection will be distributed to one of the Ingress controller pods. And this will be done by kubeproxy, the internal Kubernetes load balancer. And it is important for the load balancer to be highly available here for the basic TCP load balancer. And by the way, this basic TCP load balancer can be NGINX as well. For Kubernetes clusters deployed in the cloud, you can expose the Ingress controller through a cloud load balancer. This option is very similar to the previous option for on-premises clusters. However, in this case, instead of deploying and configuring a basic TCP load balancer by yourself, you let Kubernetes allocate and configure a load balancer for you. This is possible when you create a service with a type load balancer. Clients will access the Ingress controller through a public IP of the cloud load balancer. And it is good to know that the cloud makes sure that the load balancer is highly available. Now we are back to our application. We deliver the application through the NGINX Ingress controller inside the cluster, which is running inside the cluster. The Ingress controller provides layer 7 routing and terminates TLS connections. To expose the Ingress controller, we choose to use a basic TCP load balancer. Clients connect to the application using the public IP address of the load balancer. To access the application, clients use its DNS name. The DNS name is resolved into the public IP of the basic load balancer. And now let's see the NGINX Ingress controller in action. In our demo, we will use NGINX plus Ingress controller to deliver a simple web application. And we will use a cluster with 3 nodes. The cluster is running on Google Kubernetes Engine. And if we run kube-control get nodes command, we will see that we have 3 nodes in our cluster. Before the webinar, we have already deployed the NGINX plus Ingress controller. It is running in the dedicated namespace called NGINX Ingress. Let's see the main components of the Ingress controller installation. For that, we run kube-control get deployments, services, deployment pods and services, and we make sure to specify the correct namespace to use, NGINX Ingress. And first here we see the deployment called NGINX Ingress. The deployment creates exactly one NGINX Ingress controller pod. And below the deployment here we see that pod. If necessary, we can always increase the number of Ingress controller pods by scaling the deployment. And we also have a service with a name NGINX Ingress and a type load balancer. And we use this service to expose the Ingress controller pods to the clients. As we mentioned previously, for a service with a type load balancer, Kubernetes allocates a cloud load balancer, and clients can access the pods of the service via the load balancer external IP. And we will use this external IP to access our Ingress controller pods. Now we'll connect to the NGINX Plus dashboard. And for that, first we will use kube-control port forward command to set up port forwarding from our local machine to the Ingress controller pod on port 8080. And our dashboard is exposed on port 8080 of the pod. Let's run this command. Good. Now let's open up web browser. Now if we go to localhost port 8080/dashboard.html. Now we can see the dashboard of NGINX Plus. The dashboard shows the various metrics in real time. For example, you can see the number of active connections and requests per second. Since we haven't created any Ingress resources yet, there are not many metrics for us to see. So let's deploy our web application. And we will use a YAML file to define our deployment manifests. So let's look into the YAML file. We can see it on the screen. Here we define a deployment with a name hello in a namespace default. The default deployment deploys 2 replicas of our web application pod, and each pod consists of exactly 1 container. Container image is available through Docker Hub at the NGINX demos-hello repo. And this image includes a simple web application running on port 80. And notice how in line 10, we assign the label applicable hello to every created pod of this deployment. And below the deployment, we define a service with the name hello service. And the service exposes the pods of our deployment internally inside the cluster via port 80. And the server selects the pods of our deployment via this selector app equal hello. Now let's go back to the terminal and create our deployment and service. Cube control create -f hello.yaml. Now let's check that the pods are running. Cube control get pods. We see that the pods of our web application were created and running. So now we will deliver our web application. And let's look into the Ingress resource. This is our Ingress resource. We gave it a name hello Ingress, namespace default. And in line 6, we have this annotation. So it is possible that you can have multiple Ingress controllers running inside the cluster. For example, in addition to the NGINX Ingress controller that you install by yourself, as we did, you can also have the Ingress controller that is included by your Kubernetes platform. For example, an Ingress controller for a cloud HTTP load balancer. This can be an Ingress controller for a cloud HTTP load balancer. And this is true for Google Kubernetes engine, which we're using. So to make sure that only NGINX Ingress controller handles this Ingress resource, in line 7, we use the Ingress class annotation and with the value NGINX. And the value NGINX makes any other Ingress controller ignore this Ingress resource. In line 13 to 20, we define a routing rule. Every request with a host header equal to hello.example.com and with a URI that starts with / every request like that will be routed to our application. And in line 19, we specify the application by the service name, and this is a service that we have created in the previous step, and by the service port. And in lines 9 to 12, we configure TLS termination. For configuring TLS termination, we need to store the certificate in a separate file in a separate resource called of the type secret. and this is that resource. So here we, in its field TLS.30, we store the base64 encoded TLS certificate. In the field TLS.key, we store, we put the base64 encoded TLS key for our application. And if you go back to the Ingress resource, so in line 12, we configure TLS termination for our application, and we use the TLS certificate and key from the secret hello-secret. Let's go back to the terminal window, and let's create the secret and the Ingress resource. Now we will go back to a dashboard, and we can see that two tabs appeared, the server zone tabs and the upstream tabs. So let's look into this tab. And here we see the metrics for our web application hello.example.com. And since there is no traffic coming to our application yet, those values, the values of the metrics are 0. And let's take a look into the upstream tab. Here we see the 2 pods of our web application, and also some metrics. And again, the metrics are 0 since not traffic yet. Let's connect to our application, and we will use its DNS name hello.example.com. And this DNS name must be resolved into the IP address of the Ingress controller. So what we did, it was implicitly here's our etc.-host file. What we did, we mapped the DNS name hello.example.com to the correct IP address in the file. It is host. So let's go back to the browser window, hit enter, and now we're connected to our web application. And as you can see, this web application returns a simple web page, the web page that includes the IP address of the pod where this application is running, and also this name of the pod, as well as the date and the URI. And if we refresh this page, and we see that the IP address changed, and this means the response came from a different pod. And if we refresh the page multiple times, we will see that every time the response comes from a different pod. And this is because NGINX plus Ingress controller is load balancing requests among the pods of web application using the default round-robin load balancing method. Now let's generate some traffic to our web application. And we have an instance in Google Cloud. And in that, here we will use the WRK tool to generate some traffic to our web application. So let's run it. And if we go back to the dashboard, we see that the traffic, we see that the metrics are not zeros anymore. We see that the requests are coming to our web application. So what we will do now, we will scale our deployment. We will scale our web application from 2 pods to 5 pods. So let's do this. We'll split the screen. And we scale the deployment. And we use kube control scale deployment command. And we specify the number of replicas we need. So we are going from 2 to 5 replicas. I forgot to specify the name of the deployment. In this case, it has a name hello. Let's try again. The deployment scaled. Okay. As you can see, the Kubernetes quickly created pods, and those pods, the IP addresses of those pods were quickly added to the Ingress controller by the Ingress controller to NGINX Plus. So if we go to the main tab here, we see and take a look at the uptime metric. The uptime means the time passed since NGINX Plus was started or reloaded. And since we scaled the deployment about a minute ago, but NGINX Plus was reloaded 4 minutes ago, and this means that the IP addresses were added to NGINX Plus. IP addresses of those pods were added to NGINX Plus on the fly without reloading its configuration. And this is in contrast with NGINX open source, where such a change would require a configuration reload. Minimizing the number of configuration reloads makes the Ingress controller more reliable. And this is especially for the large-scale application delivery. And this ends our demo. We saw how to deliver a simple web application using the NGINX Plus Ingress controller. Please note that for the NGINX Ingress controller, for the open source NGINX Ingress controller, this demo works the same way, except for the dashboard and the dynamic reconfiguration part. Many of you probably heard about Prometheus, and perhaps some of you are already using it. Prometheus is a popular open source monitoring solution, and it is extremely popular among Kubernetes users. And we are very happy to announce the NGINX Plus Prometheus exporter. In our previous demo, we showed the NGINX Plus dashboard, and most of those metrics that were available through the dashboard can be exported to Prometheus. Our Prometheus exporter is currently in preview, and we invite you to try it out. And you can start using it with the NGINX Plus Ingress controller. On this slide, we visualize NGINX Plus metrics stored in Prometheus, and we used Grafana for that. The metrics were collected from a single NGINX Plus Ingress controller pod. On the top graph, we show the values of the total requests per second metric. The total means that every request that was handled by NGINX Plus counts. This graph roughly shows the load that the NGINX Plus Ingress controller pod is experiencing over a period of time. On the bottom graph, we show the same requests per second metric, but only per each upstream. Here, we only count the requests that were proxied to one of the 3 upstreams. And from looking at this graph, we can see how exactly the load is distributed among different upstreams. And this is just a simple example of what you can do with NGINX Plus metrics stored in Prometheus. Now that we saw the demos, let's review the table with our application delivery requirements and see whether we successfully address them. Well, number one, the stable public endpoint is provided by the Ingress controller along with the basic load balancer, through which we expose the Ingress controller. Number 2, 3, and 4, Kubernetes by itself helps to address some of those requirements. A number of client requests, as the number of client requests increases, scaling helps us to maintain the acceptable level of application performance perceived by the clients. And also, Kubernetes restarts or recreates any failed workload, which adds reliability to the application. However, by itself, Kubernetes cannot fully address those requirements without having a load balancer, such as the Ingress controller, without having a load balancer in front of the application. As we saw, it is extremely easy to create and use Ingress resources. That's number 5. For visibility, NGINX Plus Ingress Controller provides a lot of valuable metrics, which allow us to assess how applications are being delivered. For security, the Ingress resource allows us to configure TLS termination. And finally, the Ingress resource allows us to route requests to our application using layer 7 rules. So as we see, all of the requirements were successfully addressed. There is a downside to the Ingress resource. Ingress rules are basic. They support only 2 things, TLS termination and the host header and URI-based routing. And you might ask, how do we support advanced use cases? There are a lot of cases when you want the Ingress controller to support things like session persistence, requests and rate limiting, rewriting the request URIs, the things that NGINX is pretty good at. And at the same time, you also might want to customize the behavior of NGINX. For example, enable or disable HTTP2, choose a load balancing method, or change the default SSL protocols and ciphers. First, let's see how to customize NGINX behavior. And there are 2 ways. The first, the config map resource. This resource is useful for storing arbitrary key value string pairs. If you deploy a config map resource with the name NGINX config and in the same namespace as the Ingress controller, the Ingress controller will use the content of the config map, and it will use this content to customize NGINX behavior. For example, on the left here, we have a config map where we enable HTTP2, change SSL protocols, and change the load balancing method. But keep in mind that customizations defined in the config map resource will be applied globally for all Ingress resources. And if you want to customize NGINX on per Ingress basis, you can use annotations for that. Annotations are key value string pairs, which you can add to any Kubernetes resource, including the Ingress resource. NGINX Ingress controller understands certain annotations. For example, on the right, we use an annotation to change the load balancing method to IP hash. In this case, we override the load balancing method, which we set in the config map resource on the right. Advanced NGINX features are also available through annotations. In this example, we use annotation to configure JOT validation. JOT validation is handy for authenticating client requests. NGINX Plus will ensure that every client request has a valid JOT token with it. And NGINX Plus will reject any requests that don't have a valid token. Be aware that the annotations that work for both NGINX open source and NGINX Plus are prefixed with NGINX org, as an example here, and annotations that work only for NGINX Plus are prefaced with NGINX com. And in this example, we have the annotations that work only for NGINX Plus. Annotations and config map keys, they don't require you to know a lot about NGINX configuration, as we saw in these examples. And snippets are a special case of annotations and config map in the config map keys. Snippets allow you to work directly with native NGINX configuration. And you can use snippets to insert configuration into global HTTP server or location context of NGINX. In the example here, we use snippets to insert configuration into the location context. This configuration makes NGINX set additional headers when it passes a client request to the backend. If you want to use some advanced NGINX features and you cannot find an annotation for it, snippets become extremely handy. However, you need to learn some NGINX configuration. The Ingress controller uses templates to generate NGINX configuration. In rare cases, to support some advanced requirements, you would want to change the templates. To change the template, you need to download the Ingress controller, download Ingress controller sources from GitHub, change the template file, and then you need to build your own Ingress controller image, which will include the modified template file. And as with snippets, to successfully change the template, you need to learn NGINX configuration. Let's summarize the available methods for customizing NGINX and supporting advanced use cases. The easiest ones are the config map and annotations, and because they don't require you to learn about NGINX configuration. And snippets and changing the template are more advanced methods. We only recommend using them if you can find the right annotation or the config map key. You will find that there are two NGINX Ingress controllers out there. There is one in NGINX Inc. GitHub repo, and there is another one in Kubernetes repo. Which one should you use, and what are the main differences? In this table, we compare the Ingress controllers. The Kubernetes NGINX Ingress controller is represented by the first column. It is an open source project. It was created by Kubernetes community. Similar to our Ingress controller, it supports the config map and annotations. It also provides an extension to support TCP or UDP load balancing. It's worth mentioning that the version of NGINX that is being used here is a custom build, which includes several third-party modules. Our Ingress controller supports both NGINX and NGINX Plus, and that's why we have two columns on the right. The Ingress controller was created by us with some help from the community. As we saw in our demos today, the NGINX Plus Ingress controller, this NGINX Plus Ingress controller, you can get advanced features not available with NGINX. Features such as dynamic reconfiguration, jot validation, and extended status. And you will also get support directly from our engineers. All the Ingress controllers are used in production environments. And for example, with our Ingress controller for NGINX, we know that it was downloaded more than 1 million times from Docker Hub. Today, we saw how to use NGINX Plus Ingress controller and how to successfully deliver a web application on Kubernetes using NGINX Plus Ingress controller. Our Ingress controller gives a scalable solution for application delivery with high performance and stability. It is very flexible, both in terms of how you deploy it and how you configure it. With annotations and the config map, you can use advanced NGINX features and customize NGINX behavior. And you get even more features with NGINX Plus Ingress controller, such as extended status in dynamic reconfiguration. Our Ingress controller is available on GitHub via the link below. If you would like to try it with NGINX Plus, you need to get the NGINX Plus license first, and you can request a trial license by following the link at the bottom. And now we will have some time to answer a question. And back to you, Stephen.
Thank you, Michael. As a reminder, if you have any questions, please submit them via the questions box on the GoToWebinar control panel. And as a reminder, there is a prize for the best question.
Okay, so the first question, what about high available configuration without any service interruption? For example, in case of more than one load balancer. Well, as we saw, let's go back to our diagram probably. As we saw, for application delivery, here we suggest this architecture when you have multiple layers of load balancing, and the Ingress controller layer where you do layer 7 routing, and then you have basic load balancing in front of the Ingress controller, through which you expose the Ingress controller. And because of this architecture, assuming that the basic TCP load balancer is highly available, and then we have the multiple Ingress controller pods here, and in case of if a pod fails, Kubernetes will recreate that pod. So the whole thing together helps to get a highly available and reliable system. Well, I hope that answers your question. Okay, we have next question. We're using the open source version of NGINX. Is there any latency before a new rule is executed by the load balancer due to reload? Well, so once you add a new rule, let's scroll back to our Ingress controller diagram. Once you add a new rule, the Ingress controller can see that almost immediately through the API, and then it generates the new configuration for that rule and reloads NGINX. So there will be some delay between the rule was added and it was generated, and then to apply the rule, the Ingress controller reloads NGINX as well. So there will be a delay, but it usually takes 1 second, 2 seconds. But actually, it usually takes less than one second. And in the question, it was said that due to restart, so no restart, there's no restart, only reloading. And NGINX and NGINX Plus support a graceful reload. So no connection is dropped, and and NGINX doesn't drop any incoming connections as well during reload. So the question is, maybe you said that NGINX may substitute kubeproxy too. What are the benefits or improvements? So in this case, NGINX doesn't substitute kubeproxy. I think I mentioned kubeproxy here in this architecture, where the distributed connections, client connections from the basic TCP load balancer, they are distributed among the node ports, and then once the connection hit the node port, it will distribute it to the appropriate NGINX Ingress controller pod, and this is done by kubeproxy. But by itself, NGINX, as we saw we can go back to our dashboard here in the upstream. So this is NGINX has direct access to application pods, so it connects to them directly, and this is true for both NGINX Plus and NGINX open source. So it connects directly to pods, bypassing the kube proxy. And the reason why this is a good thing, because, for example, you can change the load balancing algorithms, how you distributed requests among those pods. You can add things like session persistence, so the request will be routed based on the presence of some cookie in the request. So by not using kube proxy here, you get additional benefits. Well, at least you get better control of request distribution, of the request distribution. What about OpenShift and other Kubernetes platform as a service? Well, OpenShift is a special case. They have things similar to Ingress controller called a router, and there's a special resource called the route. But since the recent version of OpenShift, I think 3.6 or 3.7. Oh, yeah. So, you can run Ingress. OpenShift understands Ingress. You can create Ingress resources there, and you can also deploy the NGINX Ingress controller on OpenShift as well. And we have an example of a deployment for an OpenShift on our GitHub repo. Okay. Is it possible to have UDP load balancing? Well, we currently don't have it. We're planning to add it soon, but as I mentioned, the other NGINX Ingress controller, the one that's created by the community, has this extension. Well, the list of the question is, where do I find a list of supported annotations? So this is again on our GitHub. You can find a list of supported annotations. And note that annotations are most of the annotations are not portable when you move from one Ingress controller to another. The annotations such as the Ingress class here is common among all Ingress controllers, but once you introduce annotations for specific features of a particular load balancer, the annotation is usually not portable if you move from one Ingress controller to another. Is it possible to configure TLS termination for non-HTTP TCP port with NGINX Ingress controller? You can. There is a notation with which you can change the port. Which NGINX will listen to. So you can, instead of port 443, you can have port 8443, for example. Question: NGINX Plus dashboard is also available on NGINX. So it is not available on NGINX. So it is a feature of commercial product. But the dashboard itself is it's also worth noting that it is a dashboard, but this is just a web page that calls NGINX Plus API to get all the metrics. So all the metrics are available through the API as well. Well, there's another question. Reloading NGINX raises the memory requirement, so you rate limit the reload frequency. So this is one of the when I showed you the demo and when I scaled the deployment, So with NGINX Plus, it solves this problem for some configuration changes, such as when you add or remove endpoints. So we can quickly do it again. Maybe later we can scale the deployment back to 2 replicas. And you see that the NGINX Plus was updated, and again the uptime is now 21 minutes. So NGINX Plus is not reloaded when changes to the endpoints happen. The question: will there be support for regex-based path? Well, it is not currently on our near-term roadmap. Do we have examples in the field using NGINX Ingress controller with Azure Kubernetes Service? Does it work with Azure Container Service? Well, it works, and the way you deploy it on Azure Kubernetes Service is similar to the deployment for Google Container and Kubernetes Engine that we had here. So you deploy it similarly with having a cloud load balancer in front of the Ingress controller pods. Is it possible to use your metrics to scale out in pods of an application? Well, it is. I'm sure it's possible, but metrics are available through the API, so you can grab them. But we didn't write any software that can do that. So you need to write some script, some software that will grab the metrics, make the decision, and then scale, or integrate with Kubernetes autoscaler in some way. But I'm sure it's possible. So it is now 11 a.m. Stephen.
Thank you, Michael, and thank you all for attending.
Yep. Well, thanks everybody, and the questions. Thanks for the questions as well, and thanks Stephen for having me.
Thank you, Michael, and thank you all for attending today's webinar and for your great questions. We hope you found the webinar beneficial.